So these problems say show that the sequence is geometric, then find the common ratio and write out the first four terms. So the first thing I'm going to do here is kind of rewrite this because I want to think of the form. When I'm thinking of geometric series, I'm thinking of the form a to some a1 and r to some k minus 1. That's what I'm thinking of when I think of geometric series. Remember the formula. There it is. It says an equals a1 times r to the n minus 1. So it's exactly this thing here, and that's what I'm thinking of here for this one. So anyways, that's the idea here. So that's what I'm looking for. So when I see this, I automatically think, can I write it another way? So I could write it this way. Now, remember, the 9 doesn't have a power on it, just the 3 does. So this would really be 3 to the n. So that's really what I'm looking at for this one. So again, we have to think about these things creatively to really see what they are. Now, there is another method people use for this, but this is the nicest way to think of this. Can I get it in terms of the same power? I have to understand these power rules, though. That's the difference. Or the other one is where I take a sub n over a sub n minus 1, and then that actually equals my r as well. So what that would mean for this one then, that means that would equal 3 to the n over 9 over 3 to the n minus 1 over 9. And then when I'm dividing here, that means I flip and multiply. So this is really 3 to the n over 9 times. That means this is going to flip. It's the reciprocal of that. So that's going to be 9 times 3n minus 1. So I still have to understand that this right here cancels with almost all of those. Not quite all of them, because 3 to the n is really 3 times 3 to the n minus 1. If I look at it this way. And then that would cancel with that. These 9s also cancel. And remember, when they cancel, they don't give me 0. They leave 1s in its place. So that means this would be gone because it's up there now. Okay, so then I would actually end up with 3 times 1. So it would be just those two. So it would be 3 altogether. It would just be 3. Now look what I did. All I did here was say, hey, I'm just going to move it out. And that's what I did. So to me, that seems a lot less messy if I can just think of the simple rules of algebra, really kind of arithmetic here, but algebra for sure, because it's got an n. But that's a simple idea of how to think of it. Now, they came up with 3, and so did I. Okay, so it's your choice on how you want to do it. Now, I'm good either way, but pick a way and say, I can do it this way. Or even use both. It doesn't matter. But there they are. So now I can say that my r equals 3, which implies the sequence, and I'm just going to call it a sub n, is geometric. And then I have to find the first 4 terms. Now I can do that. I could have did that either way, even without doing any of this work. I simply just plug them in. So for instance, a1, what is a1 going to be? That simply means I plug in 1 for n. So it's going to be 1/3. So I'm just going to run through these 4 values and check yours and see if you get the same thing. So there are my first 4 terms. Okay, and that's the second part. It also told me to find r, and I found that as well, and it told me to show that it's geometric, and that does. So now let's move on to the next one. So then for this one here, we're thinking of the same idea. I really want an a to the 1 times r to the n, or n minus 1 of some sort here. Okay, so when I look at this, I'm trying to get it in that same form. So now one thing I notice right away with this is that on the top it's to the n, and on the bottom it's to the n minus 1. So the way I'm going to do this is I'm looking at the top here, and 2 to the n is the same thing as 2 times 2 to the n minus 1. Hopefully that's okay with you. Now the reason why I'm going to just kind of take it backwards, I always go for the one with the lowest power. And n minus 1 is lower than n. So I try to go back that way because it's really simple if I can think of it that way. So now to write this out then, and again, this is the form I want. So when I think of the top is going to be 2 times 2 to the n minus 1. So I'm just going to write that in for it here. So 2 times 2 to the n minus 1 over 3 to the n minus 1. And now that these are the same, notice here, these are both to the n minus 1. And I'm going to have this 2 here. That 2 is going to end up being my A1. So now, what this is going to give me here is I'm going to get a 2. And for this 2 to the n minus 1 over 3 to the n minus 1, I'm going to get this. And this tells me then right away what my r is going to be. So my r is going to equal 2/3. And that's one piece I need. And this implies that it's, and I'll call this one b of n, is geometric because I found an r, a ratio. And then furthermore, now I can find the first 4 terms very easily here. I could have from the beginning though, I didn't really need this to find those. So anyways, the first one is, I'm just plugging in 1, remember, for n. So that's going to be 2 over 3 to the 0 power. So it's going to be 2. So now remember, I'm multiplying 2/3 by this every time. So this next one's going to be a 4/3. And then I'm going to multiply that by 2/3. So that's going to be 8 over 9. And I'm going to times that by 2/3. And remember, when I multiply fractions, I multiply straight across. So that's going to be 16 over 27. Because remember, I'm multiplying the top by 2 and the bottom by 3 because it's 2 over 3 here. Okay, so those are my first 4 terms, and that's my last part I was asked for. So there it is.